Earth's magnetic field is the basis for all modern navigation.
Strong dipole magnetic field, and that prevents water from being lost from the Earth, also protects us from the deadly radiation.
Something strange is going on with the Earth's magnetic field. Over the last 200 years, it has gradually weakened and shifted its magnetic north pole from the Canadian Arctic to Siberia. However, in recent decades, the sluggish migration south has accelerated, reaching speeds of up to 30 miles each year. Could we be on the verge of a geomagnetic reversal in which the magnetic north and south poles swap roles? What is causing the Earth's poles to flip? What are the ramifications and how can you deal with them? In this video, we go into the phenomenon of the Earth's poles flipping, which is causing a great deal of concern among a lot of people because it's happening right now. The magnetic field of Earth is produced by the flow of molten iron in the planet's core, approximately 1,800 miles, 2,896 kilometers beneath our feet. This superheated liquid generates electric currents, which cause electromagnetic fields to form. While the principles that cause pole reversal are relatively unknown, computer models of planetary dynamics demonstrate that the reversal occurs on their own. This is backed by observations of the Sun's magnetic field, which reverses every 11 years. Our own magnetic field formed at least 4 billion years ago, and the Earth's magnetic poles have reversed numerous times since then. The magnetic field has altered 10 times in the previous 2.6 million years alone. And because the most recent occurred 780,000 years ago, some experts believe we are due for another. However, reversals are neither predictable nor periodic. But what exactly is the Earth's magnetic field and how did it form? You presumably know what a bar magnet acts like. Well, imagine a massive bar of magnet inside the Earth that is roughly aligned with the Earth's axes. Each end of the magnet lies reasonably close to the geographic north and south poles. Actually, there is just approximately 10 degrees difference. At each magnetic pole, the Earth's invisible magnetic field lines move in a closed continuous loop and are nearly vertical. Lines of longitude converge at the geographic north and south poles. The geographic north pole lies in the Arctic Ocean, while the geographic south pole is in Antarctica. The magnetic poles, on the other hand, are positioned where the magnetic lines of attraction enter Earth. The magnetic North Pole, commonly known as the North Dipole, is currently located on Ellesmere Island in northern Canada. Take note that we said currently located. When you follow a magnetic compass and it points north, it is aligning itself with the Earth's magnetic field and pointing to the magnetic North Pole rather than the geographic North Pole, which is roughly 310 miles or 500 kilometers away. Another feature about the Earth's magnetic poles that may surprise you is that they move with time and are not fixed. For example, when British Arctic explorer James Clark Ross originally found the magnetic North Pole in 1831, it was located on Canada's Boothia Peninsula. However, the magnetic North Pole has been migrating roughly 25 miles or 40 kilometers per year in a northwest direction since then. Although this movement is distinct from the magnetic poles flipping or swapping positions, which is far more severe. So what causes the Earth's magnetic field? Because the Earth has an iron core, the magnetic field must originate there, right? Wrong. As temperatures rise, the magnetic properties of metal begin to degrade. Since the iron in the center of the Earth is subjected to extremely high temperatures, it cannot be responsible for the planet's magnetic field. Geodynamo is what you're looking for. This is essentially what happens in a bicycle's dynamo light as you pedal. The magnets in the dynamo begin to spin, creating an electric current that aids in the production of light. However, in the case of the Earth's magnetism, the opposite occurs, since rotating an electric current generates a magnetic field. The generation of the Earth's magnetic field takes place deep within the Earth's interior, in a region known as the outer core. The slow-moving molten iron's convective energy is transferred to electrical and magnetic energy. In a positive feedback loop, the magnetic field stimulates electric currents, which generate their own magnetic field, which induces more electric currents. The Earth's magnetic field is really useful, and you practically owe your life to it. In fact, one of the reasons astronauts who are not appropriately guarded on Mars will perish is due to the magnetic field, or more precisely, the lack of a magnetic field. The magnetosphere, or protective magnet bubble, which Mars lacks, shields humans on Earth from potentially hazardous space weather such as solar winds. The sun's energy feeds us, but its byproduct is solar winds, which would have corroded our atmosphere and deprived you of the air you breathe. The magnetosphere also prevents substantial amounts of particle radiation from being emitted during coronal mass ejection (CME) events. It also prevents another deadly material known as cosmic rays from coming down on us from deep space. Our magnificent magnetosphere repels destructive energy and traps it in zones known as the Van Allen radiation belts. These donut-shaped belts of radiation can enlarge when the sun's activity increases. Of course, while the magnetosphere offers an important service, it is not flawless, and some breaches do occur. Geomagnetic storms can breach the magnetosphere and cause widespread radio and power outages during very strong space solar winds or massive CMEs. It may also threaten astronauts and contaminate Earth-orbiting spacecraft. However, the effect is not always negative. In fact, one of them is mesmerizingly wonderful. If seeing the northern lights, also known as the aurora borealis, or the southern lights, also known as the aurora australis, is on your bucket list, neither would occur if there was no disturbance in the Earth's magnetic field. The disturbance is responsible for sending ions down to Earth's poles, where they hit with oxygen atoms to produce the hugely entertaining and stunning aurora light displays. While Mars does not have a magnetic field, other planets in our solar system have. Even though scientists do not fully understand the underlying principles, Jupiter, Saturn, Uranus, and Neptune all have magnetic fields that are significantly stronger than Earth's. Venus has a liquid core, but it does not spin fast enough to generate a magnetic field. So what's the big deal with magnetic poles reversing? Is it even imaginable? The answer is yes, and the event is known as the Laschamp excursion. However, you do not want to be present when it occurs. The Laschamp event is the term given to a geomagnetic disturbance that causes the planet's magnetic north and south poles to weaken and the magnetic field to tilt on its axis, reducing its strength to a fraction of its original value. The magnetic attraction that typically drives the flow of high-energy solar particles toward the north and south poles, where they interact with atmospheric gases to illuminate the night skies as the northern and southern lights, was reduced. This occurred 41,000 years ago, and the magnetic field took approximately 1,300 years to recover. During that time, the auroras went to near equatorial latitudes where they are rarely seen, and the experience was not very rare. Scientists have determined that the field diminishes sufficiently to switch polarity once every 200,000 to 300,000 years. It is possible that the procedure will take hundreds or even thousands of years. So, how did researchers learn about this? The magnetic molecules that have been retained in volcanic deposits and other sediments provide the key piece of information. They can tell when magnetic reversals have occurred in the past because the molecules aligned with the magnetic field at the time they were deposited, indicating the location of the magnetic North Pole. However, the Laschamp event had far-reaching consequences for species alive at the time, far beyond the aurora light shows. A study of swamp-preserved kauri trees in northern New Zealand recently showed the Laschamp's fatal implications thousands of years ago. The scientists analysed the changes in carbon-14 levels in cross-sections taken from the preserved old trunks. Carbon-14 is a radioactive carbon isotope that can be utilised to investigate ancient materials. What they did was monitor variations in carbon-14 levels throughout a time frame that included the Laschamp reversal. During Laschamp, when the magnetic field was fading, their investigation revealed higher quantities of radioactive carbon in the atmosphere. So basically, their discovery was that elevated amounts of carbon-14 corresponded exactly with records of horrific global climatic and biological shifts. For example, about this time, megafauna in Australia began to decline into extinction, and Neanderthals in Europe were becoming extinct. Their extinction may have been accelerated by climate-related events in their environment. According to computer climate modelling, a weak magnetic field, as little as 6% reduction in its typical intensity, can create severe climate changes by strongly harming the ozone layer, letting in UV and changing how the Earth's atmosphere absorbs the sun's energy. Further research reveals that this period coincides with a transition in Homo sapiens cave art. Higher UV levels may have drove our forefathers into caves to escape the harsh sunlight. With lots of time on their hands while holed up, they simply started to draw and paint on the cave walls. So when is the next magnetic pole reversal going to happen? Scientists are keeping an eye out for signs such as the North Pole currently travelling across the Bering Sea and the magnetic field weakening by around 10% in the last 170 years, which suggests that another flip is closer than we thought. The flip has occurred at least 171 times in the last 71 million years, so we may be due for another. This is why they are racing to discover more about the phenomenon and how we might cope with it on a worldwide basis. So what would happen today if the Earth's magnetic poles reversed? One of the most noticeable and uncomfortable consequences would be the increase in the number of cancer cases. Remember how we mentioned the Earth's magnetic field shields us from damaging solar energetic particles and cosmic rays? Both can produce genetic abnormalities that lead to a weakening or temporary loss of the magnetic field before a permanent reversal, which could increase cancer rates. If the flip was preceded by long periods of unstable magnetic behavior, the danger to life would escalate. Another consequence are the satellites, which are already demonstrating the effect of a decreased magnetic field while in orbit. There is already a region of the Earth where the magnetic field is approximately 3 times less than near the poles. This location in the Atlantic Ocean between South America and Africa is known as the South Atlantic Anomaly, or SAA. They claim that satellites in this vicinity are prone to electronic malfunctions. The SAA was found by scientists in the 1950s, and it has since reduced in strength by more than 6%, while simultaneously moving closer to the west. While additional research is needed, the SAA demonstrates how a weak magnetic field can impact satellites, as multiple spacecraft have reported technical issues when flying over this region. Because models have shown features in the SAA spreading globally, the SAA serves as a guinea pig for exploring what a magnetic pole flip today would look like. Anything that impacts our satellites will have a significant impact on us. This implies that our electric grid may be compromised, which might lead to the loss of electronic gadgets, including home appliances and wireless equipment. The issue is that we developed our key infrastructure during a period when the Earth's magnetic field was relatively strong and steady, without taking into account events such as magnetic pole flipping. As a result, even minor changes can devastate the delicate architecture that we have developed. As a result, you may say goodbye to most of the things you take for granted. No internet, social media, YouTube, phone or GPS tracker navigation, live broadcasts, weather forecasts, environmental monitoring or communication. According to experts, you would not even have electricity to power your home. Even the most basic compass will let you down since it will point in the wrong direction. Let us know what you think about the Earth's magnetic pole reversal in the comments section.